Hi and welcome. My name is Kira and I'm an OpenSciEd teacher and facilitator. In this video, I'm going to take you through some of the key moments that occur in this lesson and also try to provide some tips to help this lesson run smoothly. I like this lesson because it gives us a brief break from the video phenomenon and it helps us understand the structures in our bodies that help us to see the things that we do. Here we go. So in the last lesson, we figured out that the student sees themselves because the light reflects off of the student and travels to the one-way mirror, which reflects about half of that light back to the student's eyes. The other half of the light transmits through the transparent part of the glass to the adult's eyes. And then we also figure out that the light that transmits through the glass bounces off of the adult back to the one-way mirror. Half of this light is reflected back to the adult's eyes off of the silver sections in the glass, and the other half transmits through to the student's eyes. So we're wondering why the music student does not see the teacher when there's an input from the teacher. So our lesson at a glance shows that this is an investigation lesson. It should take about 2 days to get through with 20 minutes of materials prep. There is a hands-on investigation and there is a video that we will be watching called The Visual System, How Your Eyes Work. So we start off the lesson by revisiting the light inputs in our model and motivating the need to know more about what happens when light enters our eyes. So then we're going to watch a video that walks us through the light entering our eyes, and we're going to develop a model together to represent what we saw happening in the video. So we'll do an investigation that shows us how the structures in our eye change the light as it passes through the eye. And at the end of class, we decide we need a way to apply this new learning to our actual video phenomenon. We begin day 2 by revisiting our new learning about light entering our eyes, and then we try to make sense of how our brain focuses on some inputs and not others. So we're going to use some real life scenarios to help sort through that. We'll create a model of this and then bring it to a consensus discussion where we will come to an agreement about why the student isn't able to see his teacher. And we think that this lesson might be one of the last pieces of our puzzle that we need to explain our phenomenon. So we're going to hopefully in the next lesson have a chance to apply this learning to our phenomenon. What we figure out on day 1 is that light changes the directions or refracts when it travels between transparent materials, and that when a light input is detected by sense receptors in our eye, it's turned into a signal that travels along the optic nerve to our brain, and then our brain processes that signal into what we actually see. So we also figure out on day 2 that when there are multiple inputs, our brain is going to respond to the strongest signal. So one of our key moments happens in part 2, and that's where we're tracing the path of light after it enters the eye. So we are going to use that video. While we watch the video, which we'll probably watch a couple times, we will record our notices and wonders, and then we will utilize those to turn this into an understanding that structures in the eye focus the light and turn it into an electrical signal. And so as a class, we're going to collaboratively create a model of this entire process. In part 3, we investigate how a lens focuses light. As the light enters the eye, we know that it changes directions, it refracts, it comes together in a small, more focused beam of light. And so we want to model this using magnifying lenses to represent the lens of our eye and a flashlight to represent the light input going into our eyes. In part 7, we're going to conduct a class consensus discussion. So we're going to apply our learning to our music student phenomenon. So we're going to build a consensus model, and in this consensus model, we're going to add and color code those inputs from the student and from the teacher. And we are going to show that light entering the eye from the student is stronger than the input from the teacher. So our brain is going to focus more on the image of the student. And from here, we think we have all the pieces necessary to explain our anchoring phenomenon. So our plan is to put all of our ideas together in the next lesson to explain our one-way mirror phenomenon. So in the video that the students watch, the video mentions light bending, and some students may interpret this as turning or curving. So remind students of the path of light and how it's always in a straight line. And this also might be a good time if you did those optional activities in lesson 2 about the path of light. This might be a good time to revisit those, and those help to kind of strengthen that understanding of the path of light. Also throughout the lesson, we're going to build multiple iterations of basically the same model. So in order to save yourself kind of the headache of having to draw this model over and over, you might consider a couple options. One would be to laminate the chart paper version and then just use like wet or dry erase markers to add in the light inputs. And then you can erase that and add in another one when we go through it again. When I do this lesson, I just layer colors on the same model. So like when we are talking about a generic light input, I'll just use like highlighter yellow and show that light going through. But then when we go to add the input from the student, I'm going to refer back to my consensus model from lesson 5 and use that same color to represent the student's input. And I'm going to draw that right over the highlighted portion that I did in the first pass. And then when we add the teacher input, I'm going to use, again, that same color that I used in the consensus model, but I'm going to put that right below that student input. And you can kind of see this process that I'm showing you, that I'm talking you through right here on this slide. So you can see that the yellow, then the red, and then the blue get added in. For our word wall, we are going to encounter a few words as we watch this video and talk through it. So we will talk about the retina, the optic nerve, and refraction or refract. Those are not words that we earn, so they don't need to be added to our word wall, but definitely talk through those and help students understand what those mean. Poster management wise, we're going to be referring back to our lesson 5 class consensus model, like I mentioned, and our science ideas chart that we've been updating throughout the unit. We will create a refraction of light model showing what we saw happening with the lens and the flashlight. But then we will not necessarily need that for any future lessons. We will be using the lesson 6 consensus model where we show the light input into the eye from the student and the teacher as we work through putting all of these pieces together in the next lesson. Thank you for going through this lesson with me. I hope you find this video to be helpful and that the lessons go well for you, and I will see you again to go through lesson 7.